Good day, everybody. This is, me again. Uh, Today we'll not be talking about this beautiful blanket or the chickens, but physics. Alright, so there's a concept out there. Let me get. Alright, so there's a concept out there, right? That pretty much states, like a rowboat, you could basically, take like a rowboat on water where you can use paddles and such to move, water from point A to point B, yada yada. You could basically do the same in space. Like, that concept is one way to look at it, but there's an entire, max base engine scenario, and all I have to say is this: they got one thing wrong. Okay, you're not basically picking up space and putting it behind you. That's not how it works. The engine that they thought of, doesn't uses that physics-based concept. What it uses instead is a concept more similar to this. Imagine my hand being imagine my hand and blanket being the engine in a way. You store up energy in your hand and you flick the blanket. Did you see that? That's basically an entire concept. The assumption is that you're basically moving mass from point A to point B. No. You see, there is no mass change in regards to this. My fingers did not become more massive when I do this, and there isn't less mass when I, flick the blanket. And as you can see, it creates a shock wave. That's the engine idea, but for space. And effectively, there's already apparently prototypes out there, using crystals as more or less springs. The same, instead of using my finger, they're using something like silicon as a spring in a way, an electrical impulse that would basically be sent into the crystal to, I guess, release the spring mechanism, or to wind it up and then turn off electrical impulse, and then it bounces off the wall, basically. And here's the thing. Does it work? Will it work? Well, here's the thing. Does this blanket move when I flick it? Yes, it does. It's that rippling effect that you see. My hand isn't moving, but the blanket is. Now, however, if we were to make this more mechanical, it would continue going that direction. Every time I flick, it wouldn't, the energy wouldn't be dispersed into a ripple. It'll be dispersed as movement, basically. So every time I would flick, I would move that direction. But it wouldn't be somewhere around 1,000 miles per hour or anything. It would be the equivalent of, depending on, how much energy and force you put into it. Think of it like this. You wind up those wind-up type springs. You press the button and the spring shoots out, right? Well, tighter you wind up the spring and longer the spring is, more energy you can put in, like potential energy you put into it. And you could theoretically shatter this wall with a spring and such. And it could go at very high speeds in the process. Well, design it, if you were to create such a scenario for, a space engine, it will work. It won't destroy the wall, but the entire craft would move that direction, at the rate of the energy output that the spring produced. The same way that a rowboat works, basically. The amount of water that you push that away, would produce the amount of thrust, or whatever you want to call it, back that away. That's the bit that they got right. But on the bit where it's like, more mass this way and less mass that way, that's not how it works. My finger didn't lose mass, but it did stored up energy. And that potential energy was released into the blankets. So yeah, if you're wondering about the scratches, they're from cats. Cats like to scratch. So, yeah. And will it work as a space engine? The answer is yes, for the concept that I just told you. And that is, imagine a ripple, instead of, the energy causing ripples, is causing movement. And, which is theoretically plausible. And given that in space, you can only build up momentum and not necessarily lose it to friction or to speed, like not like from friction because of air in the ground and such, or from gravity, such as planets. Like in a 0G environment, you can basically only gain momentum. You can't lose it. In a zero friction environment, you can only gain momentum and not lose it. And it's been theorized such engines could be used to travel from solar system to solar system. In reality, unless, let me put it like this. In reality, that's actually bullshit. Alright? Yes, you can travel solar system to solar system, but unless you're traveling from point A to point B, basically 1 billion kilometers or so per distance, you're going to leave this solar system. Like if you were like traveling from Earth to the outer edge of this solar system, traveling 1 billion kilometers an hour or so, it would take you roughly a day to travel that distance. Now, and that would be basically a light day to get to the outside of our solar system. About 24 billion kilometers lies in between you and the outer reaches of this solar system. If not 48 billion kilometers lies in between you and outside of this solar system. The only way to create a machine like this that could get you outside of this solar system within a day is if you were to create a very large complex structure that rapid fires one of these types of machines. And we all know about the mass to energy or mass to thrust ratio. That bit still exists. With thus, you would still need a wormhole to travel to the nearest solar system. So, yeah. Travel around this solar system using this technique is more viable than using it to travel to other solar systems. Don't get me wrong, it's doable, but I would highly not advise it.